Diazonium salts. See, these are very important class of compounds which are basically used to have nucleophilic substitutions on the benzene ring. We know, let us see first their method of preparation. The reaction is called diazotization. Now, what we do in this case is, we have seen earlier also in case of aromatic amines or in case of amines, when aniline is reacted with NaNO2 and HCl at 0 to 5 degrees Celsius, what we get is your this compound, which is called benzene diazonium chloride. Now, in place of these chlorides, we can also have hydrogen sulfate, bromides, etc. These also are possible. What is most important to note is this, that these arene diazoniums are stable. Now, what makes arene diazonium stable? We have seen that if this would have been your primary aliphatic amine, we get alcohol instead of getting the diazonium salt. The reason being they are not stable. So, what makes these diazonium salts, arene diazonium, stable is these resonating structures. See, we have this arene diazonium. A shift here, this is already positive, will make this one move here. This will make benzene ring acquire positive charge, which rotates from ortho to para positions. Then again to ortho position, and then it is back. Now, these resonating structures make this arene diazonium very stable, and that is why we find that they are very useful compounds at this low temperature. And because of the positive charge on this nitrogen, nucleophile can easily attack here, and we can show nucleophilic substitutions on the benzene ring. These arene diazonium chloride or salts are stable, crystalline, colorless crystalline solids. They get, of course, decomposed on heating only. Even in water they are stable, but on warming they get decomposed. So that is what are the physical properties of these compounds. Now let us see their chemical properties. See, most of its reactions we have already seen. What I am doing now is I am putting up this diazonium on one side. And I am going to write down its reactions one by one. Its one most important reaction is Sandmeyer's reaction, in which what we do is we react this with CuCl HCl. So we get, in this case, chlorobenzene. If we react this with CuBr HBr, we get bromobenzene. And when react with CuCN KCN, we get cyanobenzene. As I've told you, these all are nucleophilic substitution reactions. The nitrogen is replaced. Similarly, there is one more reaction which is called Extraminds reaction. In this, what we do is we react this with CuHCl, we get chlorobenzene. We react with CuHBr, so we get what? Bromobenzene. These all we have done in the alkyl halide aryl halide chapter. We also know we can react this with fluoroboric acid HBF4. This is going to give us this salt for a while, which on heating gives us fluorobenzene, nitrogen, and BF3. This reaction is called Ball-Schiemann reaction and is used to prepare fluorobenzene. We can react this with Ki. What we get is iodobenzene, nitrogen, and KCl. There are more reactions of the arene diazonium. They can be listed as see, it's like this. We can react them with phosphenic acid, H3PO2. It gives us benzene plus nitrogen plus HCl. In fact, it gets this H3PO2 itself gets oxidized to H3PO3. Then the same benzene can also be obtained by reacting it with ethanol. What we get is benzene, aldehyde, nitrogen, and HCl. We can react this with fluoroboric acid to get this salt. Which on reaction with NaNO2 gives us nitrobenzene plus BF3 plus N2. We also get NaF in this case. Along with this, there is one more very important reaction of this BDC, which is called coupling reaction. This reaction is basically a sort of electrophilic substitution on, like if we are having phenol, its electrophilic substitution takes place at para position. Reaction is carried out at a basic medium of pH 9 to 10. What we get is this compound. This is called para-hydroxy azobenzene, which is an orange-red dye. If in place of this, if we use this aniline in place of phenol, again at a pH of 9 to 10, electrophilic substitution takes place on aniline at para position, and what we get is para-amino azobenzene, which is a yellow dye. So this is how we have the different reactions of diazonium salts.